In the last session, we have done something those were related to some analysis, and we have done a small room project. And I need to have a, you can say, heavy project, or maybe not a small project. Okay, you can say we will have heavy project, so you guys can understand everything from the basics. Okay. For that, I just need detailed drawings, and then I may need detailed specifications. And then, of course, number three, we may need MRS. Okay, because these three are just very important for detailed cost estimate. But remember, before having a heavy project, we may need to learn some basic things about BBS, which is known by the bar bending schedule. Okay, so let me ask you: is there anyone who have any idea about BBS or not? You guys know about this thing or not? BBS. Anyone? Is there anyone, please?
सर बार बेंडिंग स्केड्यूल में जो बार के डिटेल होते हैं जो स्पीड के वही होते हैं ना सर। उसके कट लेंथ, उसका जो वेट होता है, फिर उसकी प्राइस,
Yes,
वो सारा
exactly.
कुछ।
Yes. So bar bending schedule is actually what we do, the things, okay, you can say in a whole page, we do those things only in a table. So bar bending schedule is, you can say, just a table. Okay, it's very simple. It is like a table, and we put everything over there, like maybe description, then the length of the member, the diameter, maybe the concrete core, the extra length. Okay, so every these things, and then maybe the weight of the bar, and maybe the shape of the bar, okay, etc. So putting all these things in a table is just the same thing as BBS or bar bending schedule. That's nothing that complicated, okay? So we will cover everything related to bar bending schedule. So while performing the cost estimate of a huge or maybe long project, we may need these things, okay? So therefore, today we will have some short session about this thing. Remember, we have already covered about the slabs estimation for steel, and but before doing the BBS, let me have an example related to the beam, okay, and then maybe for a column we will switch into bar bending schedule. Now, it's really important, okay? If you remember, we have done the steel calculation for a slab, okay? But that slab, it was like manual calculation. We did let me just have a pin over here, okay? For a slab, if you guys remember, we had slab having length and weight, and then there was a thickness, okay? Over there, what we did is actually we determined the bar's length, okay? The main bar's length, then we did actually the distributions or temperature bars length, okay? And based on the diameter and then the length of the bar, we actually use the formula for the weight calculation, okay, if you guys remember. So we have used two types of formulas for the length sorry, for the weight calculation, okay? But these things, okay, if you remember, we filled almost many pages, okay? However, if you do these things or calculate the steel quantity in a table, okay, that may take only one page. That's why BBS is very important. Why is BBS important? Okay, after looking into the BBS, you will have an idea about the member's steel details. Okay, like maybe the cut length of the steel bar, and then the diameter of the steel bar for the same member, and so on. That's why BBS is very important. Now, I'll just have one example, okay, and then we you can say manually, and then we will have another example with BBS, so you guys can understand how we prepare BBS. But before calculating, or you can say calculating the steel quantity and BBS, it's really important, you know, the overall calculation. Okay, so I'm gonna take just a beam, you can say. This is a beam which is 10 feet long. This is the length. And we have some information related to the reinforcement, okay? It is 18 inches. You can say the height is just 18 inches, and is of course a bent up bar, okay? And we have sections. One is it mid, and there is actually one near the supports. So if you remember from the first lecture, we have talked about that drawing is really important in order to have detailed estimate. So you must be familiar with drawings. I'm not going to teach the details of the drawing, so we will directly calculate the quantities. Right. So the steel quantity in the given beam, what should be the steel quantity in the given beam? Remember, in order to calculate the weight of steel, we just need actually the length of the steel bars. Okay. And the length can be actually determined from the number of the bars. Okay. I mean, the overall length. We have actually different types of steel. You can say the stirrups, okay, which are the rings. And then we have the main bars, which are actually the straight bars, okay? And two actually bent up bars are also included over there. So the straight main bars, those are actually four a number because two are bent off, okay? It means we have only four. Now the total cut length for the bars can be actually the length of the beam, which is 10 feet, and at each end there are actually 90 degrees. Okay, you can see. Let me just circle that so you guys can see it. As you can see, we have this hook over here, another hook, and at the right hand side you can see. Okay, I have circled them with a red pen. Okay, so those are hooks, and as you can see, they are labeled as uh, they can be actually 9D. Okay, so it means 9 times the diameter of the bar. So what we have actually, the total cut length of the bars is 10 feet, and then we will actually add extra length or maybe the hook's length, okay, and that is actually 9D. But before that, we may subtract the concrete cover, which is not that necessary for a small project because it does not that increase the weight of the bar, okay. However, you can even just subtract the concrete cover. So two times concrete cover for one side and another side, and that is actually known, okay, over there. Now, two hooks just for one side and another side, they can be added. And what we have is really, this is the length of one bar, okay. That's why we have to multiply the length of one bar with the number of bars, so we have the total calculation, okay. Or maybe you can say the total cut length for all bars. As you can see, we have 10 minus 2 times concrete cover. Concrete cover is 1 inches. That's just known. You can see it in the sections. Okay, we're here. And then we add two hooks. You can say 2 times 9D. Okay, now 9, that is just a digit. D, that is 6 by 8 inches. Okay, the diameter of the main bars, that's known. Okay, and that is number 6. It means 6 by 8 inches. Okay, you can see it. We're here. All right, and then we will multiply that with the number of bars, which are 4 if you see in this section, okay? I'm not talking about the total number of bars because there are two bent up, okay? I'm just talking about the straight main bars. Now do some maths, you can get actually 43.83 feet, okay, is the length for the 4 bars. Okay, it was very simple. Now, the steel for the bent up bars are only 2, and the length calculation can be actually something little bit different because we have bends over there, okay, two bends, and that is actually at 45 degrees. So let's have another page. As you can see, I'm going to draw the same section again, so we can have some details over here. Okay, as you can see. What do you mean by the L by 4? L by 4 means the bend is just starting, okay, at distance L by 4 from the support. That's very simple, okay. As you can see, we can start the bend, okay, when we cover L by 4 length of the beam, and then of course the bend can be started. The B, that can be something, the length of the bend length over there, that can be actually something, so we have to calculate that. Now, actually, L can be determined using some trigonometric ratios, okay? You can consider that triangle, which has 45 degrees is the an angle, you can say. Let me just erase these lines so we can see it clearly. So what should be that length? I mean, this length for the bent up bar. That can be actually h by sine 45, okay? I'm not gonna go into the trigonometric ratios in detail because you guys should be familiar with this, and we have already discussed it before. So h by sine 45, h, that is known, 16 inches. And how 16 inches? Of course, we have subtracted 2 times concrete cover, okay, for the height. and the total height is 18 inches. So subtracting 2 inches is concrete cover for one side and another side. That can be actually then 16 inches is the effective. You can call it effective height, doesn't matter. So h that is known, which is 16 inches, and we will divide that by sine 45. So we can have actually 22.627 inches. Very simple, okay? And that's actually the length. It means now we can calculate the L by 4 and then we can add all these together. So we can have actually the bent up bar's length, okay? It's very simple. Now, what should be L by 4? As you can see, we have the length is 10 feet and divided by 4. So we can have 2.5. We can put those values over there, okay? Very simple. Now, what should be Y? This is actually the distance of the bar, okay? You can say the distance of the bar between two bends. And that Y can be actually, if we just take 10 feet, okay? And then we actually subtract the L by 4 for one side and another side, which is 2 times 2.5. Okay, that's just been calculated. And then, actually, of course, we will just subtract 2 times 16 inches because this is the base of the right angle triangle. Okay, very simple. And that's gonna be Y, which is 2.34. Very simple. Now, what should be the cut length for the bar? That's very simple. Okay, we have to just add all these things. You can say L by 4. Okay, and then this Y, and of course these lengths, which is 22, and then of course L by 4 for the right hand side. Very simple. So adding all these things, we can have actually the cut length of a bar, and that should be, of course, 23.347. Very simple. As you can see, we have actually the cut length for the bent up bar, and we have the cut length for the straight bar. So we can, of course, just determine their weights. Okay, very simple. And of course, that length was just for the one bar, and of course, we have two bars. So the total cut length can be 43, and that is actually for the main bar. So just straight, you can see. Now, what should be their, weights? What should be their weights? It's gonna be very simple, okay? We're gonna put all these things in that formula. If you remember the formula, like maybe d square by 52.9 times L. Are you guys there?
Yes, sir. Yes, sir.
Now I'm adding the total cut length because the bars diameter for the bent bar and then for the straight bars, that is just the same thing. Okay, so we have 43 and then we have 23. Okay, so we can add them. So 67 feet, and just put this video in the same formula for the weight. So we can have, of course, the weight for the same bar, which is 48. And this should be actually 48 kg. It means we should demand 48 kgs of number 6 bar for the same beam. And I'm not discussing this formula again and again because we have already covered this. Okay, just moving ahead. Now, as you can see, we can actually calculate these stirrups. The rings are just known by the stirrups, okay? And the stirrups calculation is just very simple and straightforward because this is just a rectangle. So it means the stirrup calculation, we can just add the ring or maybe the stirrups parameter, and that's gonna be very simple. Now, the parameter of the rectangular portion, and then we can add actually 9D hooks, okay? These 9D's hook can be actually 2 times, okay? It can even be 1 time, like maybe 4.5 for the one hook and 4.5 for the another one. It means 9D can be taken for both. So it means the parameter of the rectangle can now be actually, if we subtract 2 times concrete cover for one side and another side from 12, this can be actually the base. Okay, you can see this base. And even I can start from the height, okay, 18 inches. I'm going to subtract 2 times concrete cover from one side and another side, and that's going to be actually this height, okay? If you see the red marker, this can be this height, because we actually have the height of the stirrup is this which is shown just in the red arrows. You can see that. Okay, that's why I'm going to subtract 2 times concrete cover for the top, which is this portion, and for the bottom, which is this portion. Now next we have actually 2 times because we have 2 sides of the rectangle. Now we will take 12 inches and again subtracting 2 times concrete cover for one side and the other side, so we can have actually that portion which is the side of the stirrup, you can say. And I'm gonna multiply this with 2 because we have 2 sides, okay, top and bottom. Now plus 9D. Now D, that is number 4. As you can see, this is sorry, number 3. It means 3 by 8 inches. And 9D means just 9 times the diameter of the bar. The diameter of the bar is just 3 by 8 inches. Just do some mathematics with this. We can get actually 32 inches plus 20 inches plus 3.375. Okay. And this is 55 inches is the total one. It's really important to remind the number of these stirrups because this is the length of one stirrup bar. Very simple. We need actually the number of stirrups. Okay, the numbers calculation for stirrup can be different. It may depends, and actually there can be different spacings between the bars. Okay, as you can see, we have 6.3 inches. You can see it over here is the spacing between those bars which are near the supports. Okay, 12 inches which is at mid span, and 6.3 inches, okay, which are actually at another end of the beam. We have actually calculated the stirrups length in feet. That's why we have just divided that by 12. Okay, and that can be then 4.6 feet. Very simple. Let's just determine the cut length of one stirrup, and that's just 4.6. Now, the total length for our stirrups, we actually need the number of stirrups, okay? And that's 14. You can count them from the long section. The long section must be given, okay? And you can just study that from the structural drawings, okay? So you can just count the number of stirrups. The total length for the all stirrups can be 64.6 inches because we have multiplied the two things. Now the weights calculation, you can use that old formula. So we can have 11 kg. And here is the final result. Number 6 bar, we can demand 48 kgs. And number 3 bar, we can demand actually 11 kgs. Is there any question?
No, sir.
Next, let me have an example. So we can do this calculation in a table, okay? I'm gonna have actually maybe a footing, okay? A footing plus column. And let me just draw the diagram. As you can see, the diagram or maybe the structural drawing may look the same thing as I'm just drawing. You can see, okay, main bars, there are ties, okay. Now, ties are just the same thing as stirrups, but this terminology is just used for the rings which are being used in column, okay. And stirrup word or maybe the stirrup terminology is used for the rings which are being used only in beams, okay. So never be confused with the tie and then stirrup. So we have this drawing, and as you can see, we are asked to determine the quantity of the steel, okay. It means the BBS may be just formed, and we will calculate the quantity of steel in a BBS, okay. Now, if you remember, bar bending schedule, it is just the same thing as a table. So I'm gonna draw a table first. And in the table, we may have different parameters such as the serial number, then there can be description, okay, there can be actually the length of the member, there can be the concrete core, there can be extra length, okay, and so on. And the BBS is actually never static, it is dynamic. The number of columns may change. If you need extra information, you can increase the number of columns. That's very simple. We may have the number of bars, we may have the total length, and then the weight. There can be another column for the shape, okay, and so on. Now, in the description, let's say if we determine the bars, okay, which are actually at the base, okay, and that is 16 mm at 15 inches center to center. Now, the overall length that is known, which is actually 1 meter or maybe 100 centimeters. That's just shown, as you can see in the same drawing. It's over there. Now the cover that is known, which is actually 5 centimeters cover, okay? But we will actually subtract 2 times concrete cover from one side and another side. That's why I have put minus 10 centimeters. Now the extra length, if there is any hook, if there is any overlap, maybe double bars, okay, you can just add them with the length of one bar. So extra length, there is no extra length because it is just 1 meter, okay? We cannot provide overlaps over there, and actually, of course, hooks are not given in the same section. You can see the section, there is no hook, okay, for the main bars or maybe distributions bar which are at the base. All right, now the cut length of one bar, this is very important. We will take the total length and we will actually subtract the concrete cover from one side and another side. The total length that is 100 centimeters and concrete cover is 5 centimeters. It means 100 minus concrete cover for one side, which is 5 centimeter, and for another side, which is 5 centimeters. So we can have actually 90 centimeters. We have the number of bars. If you remember from the previous session, okay, we have done that for a slab maybe. We have taken the length and then divided by the center to center, and an extra bar can be added. So the number of bars can be 90 and divided by 15, which is center to center. It is just, if we see that's given in the same diagram. And of course, we add extra bar, which is 1. Now, never ask me why 1, because we have discussed all these things in the previous sessions. Now, the number of bars can be actually 7. That's very simple. 7 times 2, because we have 2 directional bars. As you can see, we have 16 mm at the rate 15 centimeters center to center, but both ways. That's why we have multiplied that with 2. Now, the total length can be actually the length of 1 bar, okay, times the number of bars. Are you guys hearing me? Because my internet connection is a little bit unstable.
Yes, sir.
So the total length can be now actually the length of 1, which is 90, and we will multiply that with the number of bars, okay? As you can see, cut length of 1 is 90, and the number of bars are 14. So we have the total length, which is 1260, okay? Now the weights calculation is just the same process. You can do that. It's gonna be very simple, okay? But I'm not gonna calculate the weight now. The vertical main bars, which are actually 4 in number, and those are 16 mm diameter. That's just shown over here. As you can see, we have 16 mm dia, and those are 4 in number, okay? If you draw a section, like maybe just a section, they may look the same way like this, okay? Here are 4 bars. So the overall length, that can be 432.5, and you can just calculate that, because in a rough page, you can say 25, which is also just actually the height of the footing. Let me just circle that so you guys can see it. Okay, that one, 25 centimeters. And then we have actually 30 centimeters, which is this height, okay? You can say below the ground level. Then we have 60 centimeters, and then of course 3 meters, or maybe 300 centimeters. And this 15 is actually the same thing as this 15, which is actually the mat's height. Okay, you can say that concrete. Now, 15D hook can be added for one side and another side. And this is actually the extra length. That hook can be added for the top, which is 2.5. And 2.5 is actually just the diameter of the bar, which is, you can say 16 mm and times 15. So 16 times 15 can be something, mm, you can divide that by 10 to have that in centimeters, okay? And we can have actually the total is 432.5 centimeters, okay? Very simple. Now, we can put the cover is -5, because that's just known already, okay? In the diagram, you can see that. And the extra length, that is 48. Why 48? Because we have actually 15D plus 15D for one side and another side. Okay, I mean for the top and bottom. And that is just the same thing is 48. So we can just put extra length, okay? And however, for the base, there we had no extra length, okay? This time we have extra length because we are providing hooks, right? And that is 15D. Now the cut length can be actually something which is 472. And how this comes actually, we have just added the, you can say 432.5 with the hook's length. That's very simple. We can just have the total length, and that can be now actually the cut length of 1 bar times the number of bars. That's going to be very simple. The number of bars are 4. You can just count them from the section again and again. As you can see, that's just over there. And the length of 1 bar, that is just known, which is 472.3. And times 4, we can have actually 1889.2. What we have is actually the total, because we have the same diameter for the bars in the base and bars in the, you can say the longitudinal bars, okay? So that's 3,149.2 centimeters. You have added them. It means you can even calculate their weight just by simple formula. Okay. And that is 49.7 kg. How 49.7 kg? It's the same formula. You have to just only have some footings, okay, and add formula, which is actually like d square by 162.198 times the length, okay? And that's just calculated, okay? I'm just skipping this because it's just time wastage. Now ties, or maybe you can call them with rings, okay? So ties and rings, these are actually the same thing. And if you remember, ties are just only used is term for the vertical members, okay? Now the overall length, what should be the overall length for the ties? The cut length of one bar, that is 66. How 66? As you can see, we have the square, you can say the column is square, it means the tie can be square. As you can see, this is 20 times 20 centimeters. And there is actually 10D hooks this time, okay? In the previous example, we had 9D. So it means calculation for the same cut length or maybe the tie's length can be very simple, like maybe the perimeter of the ring plus hooks. Now the perimeter of the ring can be different thing, like maybe we will subtract concrete core for one side and another side, and that is 5. Now I'm just multiplying this with 4 because we have 4 sides of the square. And that's gonna be actually very simple, which is the length of the tie, and that is 60 plus 6, which is 66 centimeter. Study this thing in detail, and if there is any question, you can ask me in comment section, okay? I'm skipping multiple things, okay, because we don't have much time. Now, as you can see, the length that is just known, the cut length of 1, which is 66. Now, the number of bars, it means the number of ties, that is 23. How 23? It's also very simple, okay? What you have to do is actually divide the height of the column or maybe the length of the column from the base till the slab, okay? By the center to center distance of the ties. And the center to center distance that's just known, which is 20 centimeters. You can see that in the diagram. We have actually the height. It is the same thing as the length of the main bar. But however, we may subtract the hooks for the top and bottom, okay? And then divide that by the center to center of the tie. And however, we can add one extra ring for the top, maybe, or maybe for the bottom. The number of ties can be actually the length of the main bar, which is already calculated a few seconds ago, and divided by the center to center, which is 20 centimeters plus 1. And we have actually the number of ties, which is 23. So we can put that video over here. You can see that it's already been over there, right? Now next, what we have to do is actually to calculate the total length, and that is 66, which is actually the length of one bar, times 23, which is the number of ties, okay? So we have 15, 18 centimeters, okay? And the weight can be calculated using that old formula. Very simple. So the weight can be 3.5 kgs. I'm not gonna do this, the weight calculation, because that's very simple. So the final results are 16 bars can be demanded is 50 kgs, and 6 bars can be demanded is 3.5 kgs for the same column and footing. Now ask me if there is any question. All right. Now, it's also important if you see, if the project is heavy project, we actually may need to determine the binding wires. However, for a small project, let's say if this is only a column, then the binding wire for this can be very little thing, okay? Maybe 1 kg or maybe 2 kg, okay? Maybe less than that, okay? So it's never necessary. You can just demand it maybe like lump sum, okay? However, if the project is heavy, then you have to determine the quantity of binding wire as well. And remember, binding wires, these are actually small, you can say, are bars with very small diameter, okay? And they are just used, you can say, to bind reinforcement with each other together, okay? So while placing the concrete, and that may not result in any moment, okay? So the reinforcement just actually stay on the place. Now, the quantity of binding wire may depend actually on the structure type, the type of the bar, okay? I mean the type of, by type of the bar, I mean the diameter of the bar, okay? If the structure is heavy, then the quantity of binding wire can be, you can say, maximum, or maybe you can say the quantity of binding wire may increase if the structure is just actually heavy. And if the bar's diameter is actually more, then the quantity may decrease, because with a huge diameter, the bar may stay on the place and there may not be any requirement of the binding wire. So it actually depends on these two parameters. Okay. Now let's just have an example so we can understand the calculation process for the binding wire. And of course, there is no specific calculation. I mean, there is no formula. There is no some rules, okay, to calculate the binding wire. Okay. And that's why we actually may depend on the past experiences. Like maybe if there is any project you have done, okay, you have to look into this project binding wire utilization. Okay, let's say in the previous project, if the cover area for the same project is 100 SFT and you have used let's say 20 kgs of binding wire, it means for the next project, if the project is just 200 SFT, then you may require actually 40 kgs a binding wire. So this is called the basic thing for the binding wire, which is actually a thumb rule maybe, and depends on the past experiences. Okay, so even there is some thumb rule you can say, and let me just show it. We're here. Okay, so according to some thumb rules, is actually you may need 9 to 13 kgs of binding wire for how much work? For 1000 kg work, or maybe 1 ton. Okay, 1000 kg, that is just 1 ton. Okay. However, this thing can be actually different if the bar's diameter is little bit different from the maybe just a minute, from 8 mm to 28 mm. Okay. So if your project contains these types of bars, maybe from 8 mm to 28 mm, and if your project is 1000 kgs, okay, then you may require 9 to 13 kgs of binding wire. And this thing, let's say if your project is actually just from 28 mm to 32 mm, then you may need actually 7 to 13 kg of binding wire. Okay, and for how much work? Actually for 1000 kg work. So this is just the basic concept. Now what if the diameter of the bars are just increasing, okay, or maybe more from 32 kg, then you may, sorry, 32 mm, okay, the diameter, I mean, is just increasing from 32 mm, then there is no need to bind the reinforcement. Okay, you may need actually what do we call that? Actually, the weld. Okay, then there can be actually the requirement of weld. So let's just have an example so we can understand this problem better. And in the example, I'll take some you can say parameters for the same example. And let's say if we are asked to calculate the binding wire required for 80,000 kg of steel reinforcement. It means, let's say if we have a huge project where we have already determined the main bars, okay, maybe for the beams, for the slab, for everything, okay, and their summation is actually 80 kgs. Now, how much binding wire do we require for the same project? You have to remember actually that thumb rule, okay, in order to calculate the binding wire for the same project. And that thumb rule, okay, you can see it. This screenshot is just available, okay. Now, the average value actually is 11 kg per 1000 kg of the work, because 9 to 13 kgs, if you take average of 9 and 13, okay, that can be maybe 11. It means 11 kgs per 1000 kg. Now, the total requirement of the binding wire can be, now we can say 11 kgs, and we will divide that by 1000. And then let's multiply this with the total work, which is 80,000. So we can have the quantity of binding wire, which is actually kg may cross each other, and there we may have, you can say, 880 kg, okay, is the binding wire. Very simple. So this is how actually we calculate the binding wires quantity. Now next, I'm gonna have another example. If you remember previously, we have done example about the slabs estimation. You can say the quantity of steel for a rectangular slab. Okay, but rectangular slab that's very easy. What if we face some slabs which are actually different and they are, let's say, not rectangular, not square, okay, then actually we may need some complex calculation over there. That's why let's just have an example for a slab which is you can say, let's say, circular, maybe polygonal, okay. So how do you calculate then the steel quantity for that slab? Okay, let's say if we have a slab maybe like this one, how do we actually distribute the rebars? It can be the same way as this one, okay? Let's say these are the main bars, okay? And the distributions are maybe the temperature bars can be in this direction. If you see, the bars are actually the length of the bars, they are just decreasing. As you can see, let's say if you take the bars at middle portion, their length is actually more, okay, or maximum. However, this bar's length, this is actually less with respect to the bars which are at the middle portion. So it means when you are just actually leading, or maybe you are looking to the bars which are at edge, okay, their length is just less. However, if you look to the bars which are maybe at middle, or maybe at you can say near to the bars you can say to the center of the slab, those are actually more, okay, in length. The length of their those bars is actually little bit more. What should be the length of these bars, okay, which are at middle, and what should be the length of the bars which are at edges, you can say. And I'm gonna have just an example so you guys can understand the problem better. Okay, let's just have an example where we have a slab, and I'm gonna say, let's say the slab's diameter. I'm gonna just draw a slab. Let me just have that, okay, little bit. Let's say it is a slab like this. The diameter of the slab, let's say that is just 2 meters. Okay, it is the same thing like maybe a slab for water tank, or maybe a slab for the manhole, no problem. And now, let's say if the bars, okay, are just running the same way like this. Okay, there are bars like this. And let's say these are the main bars, and the main bars are, let's say they are 13 mm, 10 centimeters center to center. What we have actually, let's say this, I'm going to call the central bar is L1, or maybe the length of the central bar is L1. And let's say this is L2, we have L3, L4, and so on. Okay, it's just going, or you can say the length is just decreasing. And it is also a question, how much and when do we actually recognize the length is the last length? Okay, or maybe the bar's length is the last bar length. So actually, just calculate the length of each bar, maybe L1, L2, L3, L4, and so on, okay? And when you reach to the video is 0, okay, let's say there is Ln, okay? And that length is, let's say, 0, then it means you have just completed that thing, okay? And even, you can even recognize if the length becomes minus, okay, in minus terms, you can say. So, okay, you will understand it after the example. And now, as you can see, I'm just going to calculate the length, okay? And even, as you can see, L1 can be just the diameter of the bar, which is actually 2 meter, because this is at the middle portion. However, L2 that can be little bit less than L1. And then L3 can be little bit less than L2, and so on. Now, there is a basic formula, which is a Pythagoras theorem, if you guys remember it. So we will calculate the length by r square minus h square. Okay, this is Pythagoras theorem, maybe for the half bar's length. Now, as you can see, we have two sides. It means we can multiply this formula with 2 to have the total length. Now, in order to determine L2, Okay, we're here. Let me just say, as you can see, the radius can be just the same for each L. Okay. However, the H may be different for every bar, because I'm gonna say for L2, the H can be H1. For, you can say, L3, I'm gonna write the formula in this form, like maybe R square minus H2 square. For L4, the formula may be just like in this form, R square minus H3 square, and so on. Let me just have some puttings over here, okay? So you guys can understand it better. Now, let me just make it a little bit more clear, okay? Now, what do you mean by H1? It is actually the distance between L1 and L2, okay? This is called H1. Now, H2, that is actually the distance between L1 and L3, and so on. Then H3, that is actually the distance between L1 and L4. I'm gonna erase these red work. So let me just put values in the same formula. 2 times R is just the same thing as 1, because the diameter is just 2 meters. You can see that. So it means 1 square, because R is actually half of the diameter. R can be actually D by 2. Now D is actually just 2. So 2 by 2 becomes actually 1. So 1 square minus H1. Now H1, remember, that is just the distance between L1 and L2. This is actually H1. And as you can see, the center to center, that is just known, which is 10 centimeters. Or you can say 0.10, okay, meters. So 0.10 square. And if you just calculate this by calculator, you may have the video is 1.99 blah, 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 something, okay, meters. So it is just little bit less than L1. Now I'm gonna calculate L3. Very simple, okay? And for that, I'm gonna erase these things. Just a minute, okay? And let's just put values in the same formula again. And this time for L3, okay? So L3 means 2 times R is just 1 square, minus, this time for L3, we may have H2. And H2, remember, that is just the distance between L1 and L3. This is going to be H2. So it means the center to center, which is 10 centimeter, okay, and 10 centimeters. So that's just 20. So it means 0.20, and there is actually square. Now, just have some mathematics with this formula. You can just calculate the length of the same bar. That can be actually 1.96, okay, L3. That can be 1.96. Look, that is just decreasing, okay, 1.96. Okay, and just apply the same formula, then you may have L4 is actually 1.91, and so on. The distance may actually become 0.87, maybe less than that. Okay, so if you have the same, let's say this one, now the central one is just 2 meters, then we have actually, let's say 2 meters, this is 1.99, this one is 1.96, okay, another one that is 1.91, another one that is 1.83, and so on, okay, blah, 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 okay. At the end, you may have 0.87, okay, and this is actually for the top portion, I mean for the top half slab, and for the bottom, it can be the same values, okay? And then if you just determine the same thing for the distributions bar, you can apply the same formula, but in the, as you can see, the direction is only different. This is how we can actually calculate the cut length for each bar. Now you have to add all these cut lengths, okay? You may have the length, I mean the overall length, and then just put that length in the same formula, d square by 162 times L, to have the weight of the bars.
यस सर सर आई एक्चुअली सेड दैट कि सर अगर हम देख लें कि L1 की हाइट H1 है, L2 की H2 है, तो एक्चुअली हम ये हाइट कैसे मालूम करेंगे जब हम प्रैक्टिकली कोई काम कर, तो हाइट कैसे मालूम करेंगे उसको?
ओके। ये तो ड्राइंग में तो आपको स्पेसिफिकेशन से मालूम होगा कि ये नंबर लेट से नंबर 13 बार है एट द रेट कोई भी लेट से 6 इंचज सेंटर टू
यस
सेंटर
सर।
है। इस तरह का कोई
डिस्टेंस।
इंफॉर्मेशन
अच्छा
तो
अच्छा सर,
गिवन है
ठीक
ना।
है, तो जो सेंटर टू सेंटर डिस्टेंस है उससे हमें हाइट मालूम होगी।
एग्जैक्टली तो अब देखना L1 और L2 के दरमियान क्या है, 6 इंचज का डिस्टेंस है ना।
ठीक है सर।
अच्छा।
फिर वो
तो
12 इंच का हो जाएगा इसी
तो
तरह।
ये क्या हो गया, H1 हो गया। ठीक है। अब
यस सर, फिर ठीक है,
एच
फिर क्लियर है सर।
अच्छा H2 हमारा 12 इंचज हो जाएगा।
ठीक है सर, क्लियर है फिर, थैंक यू।
सिमिलरली इतना काफी है या फिर ट्राइंगुलर स्लेब का भी थोड़ा एग्जांपल देख लेते।
सर काफी आज के लिए।
Okay, so we will actually start a project, okay, tomorrow. We may, and that project can take actually few days. After completing that project, that will be actually the end of the course, okay? So attending the project can be very beneficial for everybody because we will start that from the excavation till the top roof, okay? And then we will have the analysis, and of course we will determine the cost of the same project from the MRS. So if there is any
The course is just for the building construction, or it is also belong to the road construction, sir?
it also actually belongs to the road construction, but we have already done that, the things related to road. Uh, have you taken those classes? While we,
No, sir. Actually, I am busy on those days. That's why.
maybe the fourth and maybe the fifth class, it was related to the road estimation.
सर वो अपलोड हो गए हैं ना यूट्यूब पर?
I guess not yet. That may take a few days because due to Ramadan, it's really complicated to edit all these
Yes, sir.
videos.
Due to Ramadan, our duty timing is changes. That's why I'm not able to attend those classes.
Okay, okay. Whenever I upload that, I send actually the link in the WhatsApp group.
Okay, sir.
Okay, Allah Hafiz.